Welcome to the deep dive. We are tearing open the verifiable source material so you can gain immediate tactical knowledge. Today, we are moving past, the usual advice and accessing the foundational blueprints directly from Google's internal data streams. Our focus is on one of the most technical, yet really revealing components of that 2024 data leak, the image data protocol buffer. Think of this as the definitive technical schematic, the checklist of attributes Google uses to store, evaluate, and ultimately rank every single visual asset indexed from the web.
Exactly. Our mission today is kind of a shortcut. We want to bypass the years of public guesswork about, file names and alt text, and instead understand the deep computational principles that Google's systems are actually prioritizing. We're drilling into the data structure itself, the Google AP.contentwarehouse.e1.model.image data, to understand the foundational rules of modern image search.
Okay, let's jump straight into the architecture then. Because before Google can rank anything, it has to organize the web's massive redundancy problem. I mean, the internet is just a swamp of duplicate images. How does Google resolve that visual chaos into one single source of truth?
Right. The initial architectural design is, almost obsessive about managing redundancy. The system has to consolidate signals. You might look at an image's URL and think, okay, that's the identifier, but internally that's just a temporary DOSID. The crucial identifier, the one that really matters, is the canonical DOSID.
Okay.
Think of the URL as maybe your street address, but the canonical DOSID, that's the permanent, unique ID, the single anchor where all the ranking scores, click data, relevance metrics, everything gets consolidated.
And if that link is broken, if you don't establish that single canonical ID, what happens then?
Then your ranking signals just fragment across multiple copies. It's chaos. The entire system is built to consolidate value to that one definitive ID. This elevates originality, or at least being recognized as the most authoritative version, to an architectural necessity. Without it, the image just lacks the cohesive signal strength needed to rank effectively.
So once they have that canonical ID, the next, and I imagine often tougher, problem is proving ownership, right? How does Google actually figure out who posted that image first when it sees it on, 1,000 different websites?
Yeah, that's handled by the extremely powerful content first crawl time.
Okay.
This timestamp is basically the earliest known crawl time across all near duplicates of that image that Google has seen. By tracking the content's very first appearance, Google assigns preference to the source with the earliest verified timestamp. It uses it as a highly reliable signal for identifying the originator.
So it's a direct technical advantage to being the first one to upload it, essentially.
Exactly. A clear, explicit advantage.
But discovery doesn't guarantee inclusion, right? The source material seems to show that indexing is a highly selective process. There's a serious quality gate. What does the schema reveal about this filter?
Yeah, there absolutely is. It's a system internally named Amarna. We see references in the corpus selection info attributes confirming Amarna acts as an initial quality gate or filter. If an image fails to meet a minimum quality threshold or maybe relevance at this initial stage, it just never enters the main image index.
Wow.
And this specific non-index reason is logged internally, so they know why it was rejected.
Doesn't that make image SEO inherently less democratic then? I mean, we're not just optimizing for rank after indexing. We're sort of lobbying a black box gatekeeper just to even enter the game.
That's exactly the strategic takeaway here. Image SEO is really a two-step process. First, you have to pass the Amarna quality gate, which seems to screen for basic relevance and, minimum technical standards. And then you optimize for placement. If you fail step one, no amount of perfect alt text is going to matter. Your image isn't even in the running.
Right. And even after an image successfully gets past Amarna and gets indexed, if it's identical to others, Google still creates an internal preference hierarchy for those duplicates.
Absolutely. That's where the rank in your up cluster comes in. Even if the images are pixel for pixel identical, Google doesn't treat them equally. The copy that lives on a more authoritative domain, or the one with richer, more contextual surrounding text, or maybe the one with that earliest content first crawl time we talked about, that one receives the highest rank one within that cluster of duplicates.
Oh, okay.
This is the sophisticated mechanism that ensures, the original creator's high-quality page typically wins out over some low-quality aggregator that just scraped the image.
Okay, so Google has organized the chaos of duplication. Now they face the even harder task, I'd argue, turning that single canonical image file into usable, searchable knowledge. Let's talk about semantic mastery. How do they move beyond just recognizing shapes and start achieving, almost human-like understanding?
Well, it starts with the most basic form of information text. The schema shows a heavy reliance on optical character recognition, or OCR.
And not just one system, but multiple redundant OCR systems,
Yeah.
Okadok and Okritaser. Why the architectural need for redundancy there? Is one not good enough?
Well, redundancy tells us that accuracy in reading image text is a really critical confidence signal for them. Google needs high confidence because images, especially things like infographics or presentation slides, are often messy, stylized fonts, compression artifacts. So they're using multiple independent systems to cross-check and ensure precision. For content creators, this means text within your images, product labels, charts, whatever. It must be clear and legible. If the OCR systems can't agree on what it says, you lose a critical ranking signal right there.
Okay, that makes sense. Moving from simply reading text in the image, let's talk about linking that image to the universe of knowledge itself.
Yeah.
How does Google turn a photo of, say, a nondescript building into a recognized, indexable entity like the Empire State Building?
That direct linkage happens via the multi-bang entities attribute. This is really interesting. Objects detected in the image, whether it's a physical landmark, a specific brand of car, a historical figure, are linked directly to Google's knowledge graph. So it's not just tagged with the string building, it's linked to the definitive entity for that specific bubble.
Wow. Okay, this is critical for content strategy then. It means entity-based SEO isn't just for text anymore. If your visual content clearly features relevant entities, it becomes an interconnected node of knowledge, allowing it and the host page to rank for a much broader set of semantic and visual queries.
Exactly right. And the system knows what is in the image, but it also knows what kind of image it is. Google uses specific classification scores like photo detector score or clip art detector score to classify the visual genre.
Which means, what's the implication of that?
It means Google is matching the format to the user's implicit intent. So if a user is searching for a business growth chart, the system can filter out general photographs and prioritize clear line art, diagrams, or infographics that match that chart concept.
Got it.
This ensures the result set is functionally relevant, not just, semantically relevant based on keywords.
Right. Now, relevance alone isn't enough to satisfy the user, obviously, so we have to discuss Google's quality equation. The schema reveals this kind of two-pronged model for quality assessment. Intrinsic, meaning algorithmic beauty, and extrinsic, meaning user performance. Tell us about that.
Yeah, this is fascinating. We have concrete evidence that Google is algorithmically scoring the beauty of an image using the Neural Image Assessment Model, or NIMA. The stored scores are incredibly detailed, NIMA VQ and NIMA AVA.
Okay, break those down. What do NIMA VQ and NIMA AVA actually measure?
So NIMA VQ stands for visual quality. This scores the technical elements, the objective stuff like sharpness, focus, appropriate exposure, good lighting, the technical craft. NIMA AVA, on the other hand, stands for aesthetic appeal. This is the score for the more subjective compositional beauty, artistic merit, the overall pleasing nature of the visual.
But doesn't that raise an interesting strategic question? Google is relying on machine-judged aesthetics, NIMA AVA, which is fundamentally subjective, right? How confident are we that their machine definition of beauty aligns with actual human taste across different cultures and contexts?
That's a great point. The schema doesn't give us the training data for NIMA, obviously, but the mere presence of the score proves that investing in professional, well-composed, well-lit visuals is no longer just a soft marketing decision. It's not just nice to have. It is a direct input into the ranking algorithm. Low scores here can definitely act as a subtle drag on visibility, even if the image is relevant.
Okay. But, as always, the ultimate arbiter of quality is the user, right? And Google captures that through really granular engagement signals.
Yes, absolutely. Look at the metric HTC.
HTC.
Stands for hovers to clicks. This is a behavioral metric measuring how enticing your image thumbnail is in the search results before a full click even occurs. It basically determines if the larger impression successfully convinces the user to investigate further. It's like pre-click conversion data for the image itself.
Wow, that's pure psychological measurement happening there. But the schema also shows they know not all clicks are good clicks.
Yeah.
They built a powerful mechanism to combat misleading visuals, didn't they?
They did. That's the fascinating click magnet score. This is a specific negative score.
Negative?
Yes. It actively penalizes images that attract a high click-through rate, but do so from irrelevant queries, or what Google internally deems bad queries. So if your thumbnail is flashy enough to get a click, but the user immediately bounces back to the search results page because the underlying content failed to satisfy the query intent, that negative signal is captured here.
So it explicitly differentiates between a misleading click and a genuinely satisfying one.
Precisely. It's an anti-clickbait measure built right into the image ranking system.
Okay, shifting gears slightly, let's look at the commercial imperative, because the schema really confirms that e-commerce is deeply integrated into the image search experience.
Oh, absolutely. The presence of the rich data structure called shopping product information makes that crystal clear. It's designed to house product details, pricing, seller information, and crucially, the structure is populated by product and merchant listing structured data provided by e-commerce sites themselves.
Right.
This is the data foundation that enables images to become active points of sale directly within the search results page.
And for content creators, photographers, artists, there seems to be a literal monetization pipeline built right into the metadata fields.
Yes, exactly, through the image license info field. This container, which gets populated by industry standards like IPTC data embedded in the image file itself, or by using licensing structured schema on the page. This field is the direct driver for that licensable badge you sometimes see in image search results.
Oh, okay.
This provides a clear, machine-readable pathway for artists and stock agencies to monetize their content without relying on someone manually contacting the site owner. It connects the image directly to its licensing info.
That's huge. Finally, let's delve into safety and moderation, because the source material provides a massive insight into how safe search actually functions. It's clearly not just a simple binary pixel filter.
No, not at all. It's actually a complex fusion system. We see the initial raw computer vision analysis results things like the brain porn scores. That's the first pass. But the definitive score that determines classification and filtering is the final porn score.
Okay.
And critically, this final score combines that raw pixel data with contextual signals, and this is key, including the external search queries, the nav boost queries that the image actually ranks for.
Whoa, okay. That's a game changer. It means an image's safety rating isn't static, it's dynamic and can be influenced not just by the image itself, but by the external context and user behavior it's associated with.
Exactly. If bad actors or problematic queries are driving clicks to your otherwise innocent image, the system can actually self-correct and potentially adjust the safety rating based on that negative contextual association.
So it proves that an image is never truly isolated. Its ranking, its safety status are always influenced by the company it keeps, both on the page and, crucially, in the queries it satisfies.
That's a perfect way to put it.
So if we distill all of this ground source data, this deep dive into the protocol buffer, what does this all mean for you, the learner, listening right now? Success in image search clearly demands a much more holistic strategy that recognizes the complexity of this whole indexing and ranking system.
Yeah, I think we can summarize the required strategic alignment into three main pillars based directly on the technical fields we've just walked through. The first pillar is traditional on-page context. This is still the foundation. Descriptive file names, accurate alt text, relevant surrounding captions and text. That hasn't gone away.
Right, the basics are still basic.
Exactly.
Okay, pillar 2.
Pillar 2, and this is maybe the newer frontier, is in-image semantics. This is about creating machine-readable visuals, using clear text that OCR can actually read accurately, ensuring objects within the image are distinct and not, a jumbled mess, avoiding awkward compression that confuses the vision systems.
Making the image itself easy for the machine to understand.
Precisely. And third, and perhaps the most advanced pillar, is entity association. This means deliberately linking the visual content to the knowledge graph, ensuring the image features specific, relevant entities rather than just generic concepts. This maximizes its semantic reach and connects it to a wider web of information.
This schema really feels like the blueprint for the future, doesn't it? As search shifts toward multimodal AI like Gemini, you have to treat your images not as mere decorations, but as, what did you call them? Dense packets of structured data.
That's the idea. Information-rich graphics, entity-dense photography, and technically flawless composition will definitely be prioritized more and more by the intelligent search engines of tomorrow.
So future-proofing your image strategy means making your visuals as informationally valuable and machine-readable as your text content.
Agreed. They need to work together.
Okay, and here is a final provocative thought for you to mull over. We've seen in the source data that an image's safety score, final point score, is determined not just by its pixels, but by contextual signals, like the specific search queries, nav boost queries it ranks for. So if context can determine if an image is safe or unsafe, what other subtle contextual signals on your page, things we can't easily see in the source code or analytics, are silently determining your image's overall rank? its perceived quality, and its ultimate visibility.
It suggests the full truth of your image's value is rarely just within the file itself. It's deeply tied to the company it keeps online. Something to think about.
We'll see you next time for the deep dive.